Hi, I'm Steve. I work for School of Earth and Environment. I mainly specialise in doing atmospheric physics. My background is HPC, parallel programming, data processing. So the School of Earth and Environment is quite unique compared to other schools within the university. We probably generate 40% of all our HPC time, and probably a large chunk of all the data the university generates as well. But the university doesn't have a central storage facility for research data. The amount of data we generate is scaling on the ridiculous. We use data from many different sources from the States, NOAA, NASA, NCAR, and from Europe as well, ECMWF and the British Met Office. So we use all this data for doing things like weather forecasting, atmospheric composition, dust, sea salt, paleoclimate, which is modelling climates in the past. What happens if we doubled the amount of CO2 in the atmosphere a million years ago? What would be the impact on the weather now? Also, we do a lot of work on satellite imagery, looking at things like ice sheets, ground movement, and also paleontology. We have high-resolution images of fossils and things like that. So it's not just the data that we use. Some of these sources are petabytes of data. We also generate petabytes of data ourselves. So like ECMWF, there might be 40 years worth of wind data stored at 6 hourly intervals that we use for driving our simulations. And each of those files could be in multiple formats. But we don't use all the data at the same time. You might want to run a simulation for 1980. So you take just that year's worth of data and use it for your simulation. The next day you might want 1991. So we often have to have copies of all of this data stored for us to access locally. But the data is accessed sporadically though. Also, the modern simulations generate, the very new high-resolution Met Office simulations can generate up to a terabyte of data an hour. We just don't have that much disk space to store the results or to even run half these simulations. There's also, as been mentioned before, this new high-resolution microscopes that are coming out, CAT scanners as well. All this data needs to be stored somewhere. Now, as we're scientists, we're always funded through different research grant bodies, ERC, NERC, EPSRC. As been mentioned before, they all have certain requirements for storing their data, how long it has to be stored, what needs to be stored. Now, some of these have their own repositories like NERC, where you can store your data. As was just mentioned, we have this open access publications policy where when you publish a research paper, it needs to be stored online somewhere so anyone can come along, access the results and have a look at them. But the problem with this is there's very limited storage. It's often poorly catalogued as well. If you go to one of the sites now, it's difficult to find information that's there that could be useful to your research. The problem with this is, with the limited storage, they will let you store one paper, a PDF or a document, maybe 1 or 2 data files. Well, we don't have a few data files, we have a few million data files that are often associated with these experiments. We keep asking the question, well, you say you want us to store this data, where are we going to put it? They say they're going to pay for it, but in reality, they will let you store a select subset of your data, not all of the data. This comes to the point, what do you store? Do you store the important stuff, or do you store the useful stuff? For a simulation, there might be 100 input files, maybe 1 million generated data files, which are all useful if you want to rerun the experiment. We might do a control experiment, run a scenario for 1,000 years, let it equilibrate, and use that as a starting point for other experiments we do. We need to store that somewhere, but we just don't have the disk space. So at the moment, we delete nearly 90 to 95% of our data. We will do a simulation, get the end results, the few graphs, store maybe 1 or 2 files, then we have to wipe everything else. There's just nowhere to put it. And the big problem is discs have a limited lifespan as well. Also with research grants, they have a limited lifespan, maybe a 3-year grant. They don't give you money at the end of that 3 years to store your data somewhere else or to buy replacement discs. So we kind of just lose it or forget about it, or it gets lost in the transfer. So what can we do? This is vital information which we could reuse in 10 years' time, reanalyse. It's important data, but we just can't store it. And we're not a large organisation has £1 million budget to spend with offices all over the world. We're 3 professors who have research groups who do computer simulation work. The university doesn't have a central facility for storing all this work, so we had to do something about it ourselves. As I've said, the research grants have a limited funding. Well, one of the conditions of the grant is, apart from being open access, if someone accesses your data, you have to store it for another 10 years from the last access. So if you're storing your data for 10 years, and someone comes along in year 9, looks at the data, you have to store it for another 10 years. Where does the money come from? And where do we put all this data? So we've looked at various long-term storage solutions. We have one in England called Archivum. They will provide bit-perfect copies, but they don't provide the services that we want or the types of access that we want. This isn't data you store and you forget about. This is active research data that's used every day. Central services as well offer poor access in terms of speed of retrieval and also value for money. Our central IT facility for the university will develop a service to use, but it's 10 times the cost that a researcher can afford. So obviously the researchers don't buy into the service. We have limited money. So we had to find a better way of providing a service that researchers can afford. The big thing for us is the value of the asset versus the running costs. Central IT expects to recover the value of the asset as well as the running costs. So this is why the charge to you is so great. We needed to come up with a method where we could just recover the running costs. Remember, most of the running costs are like annual maintenance, so it's about 10% for hardware and about 20% for software. But remember, your asset could be £1 million or something in the first place. So we had to find a way to lower the costs that we could charge to researchers, something which they can actually afford and they're willing to pay for. So the big question is disk versus tape. There was a lot of bad press. From 10 years ago, tape was considered unreliable. So we had quite a struggle trying to convince people now that tape is a viable solution to use. We had to think about the lifespan, the reliability, and the university is very high on looking at the environmental impact of new services, new computers coming in. So they have to be green and efficient. So we needed a solution for active research data. This could be data sets which we read sporadically. It could be 100 terabytes of data which is generated over 6 months and we deposit 1 terabyte a week or so. We need a solution that can look at data which is not used very often, data which is used every day. And something obviously which can grow because all our data is always increasing. And the fact we had limited funding, we got the money from the school to buy a piece of equipment. We had £140,000. Yet we have to try and provide a solution for storing research data, which can at least be the starting point for something bigger. So I did the obvious thing. I compared all the vendors, had a big spreadsheet, number of tapes, number of slots, power supplies, redundancy, all the key features, quantity, quality, the reliability of the system's redundancy, the flexibility of the system, can it change with the times, and things which are important to the tender process, the environmental impact, how modular it is, can be expanded in the future, how upgradable it was. Also, looking at all the extra features, security and other things which might come in handy for us in the future. After doing this, it was quite obvious there was only one company that could provide everything that we wanted. One of our big criteria was it had to be vendor neutral. We didn't want to buy into a package where we were tied to a certain piece of software. Then 2 years down the line, we said, well, we don't want this software, we want to do something else. We want to get a bit of hardware which we knew we could use. We can change the software as we went, as our needs adapted. So, like I said, we need to get a solution which researchers can afford. At the moment for the school, they're currently paying about £100 a terabyte to buy a disk off the school. That includes the disk, someone to run it, electricity, all the usual types of things. So we agreed on that price. If we made a service which was more expensive, we would never convince them to move from disk to tape. So that's about £250 for an LTO6 tape. We have a thing called a small research facility. It's basically a piece of equipment the school buys as an asset which we know people want to use. It could be a microscope, a spectrometer, could be anything. And as part of this research facility, you buy time, an hour on the microscope, a day on a spectrometer, to do your measurements. We follow this because the big advantage of the small research facility is we don't need to cover the cost of the asset. The school buys it. It realises it's something useful we've got to use. The running costs we have to cover are just the annual maintenance a person. We agreed on a 10-year lifespan for this, which at least gives us the start of a long-term storage plan. After 10 years, if the service is a success, we get some more money, we can extend the service. And if a university finally comes to its senses and realises we need storage for research data, they might contribute to it. So we were looking for a system which we could buy where we could easily extend it by one frame, add another frame as we go on. So the costs that we need to cover are annual maintenance, software, hardware. We also put in a little bit to cover the cost of replacing the discs, the tapes, drives and the tape. So we have a major upgrade between about years 6 to 8 to replace all the hardware, the tape drives and the media. And we have half a person. Now, based on all these costs, that's about £35,000 a year to run the facility, ignoring the asset cost. Selling it one tape, though, like I said, when you use the microscope, you buy an hour's time. For the tape library, you buy a tape. So at £250 for a tape, we only have to sell 140 tapes to cover our running costs for that year. Now, we already have people asking for 5 or 10 tapes now, and the service isn't even up. We have 5 or 6 other departments, maths, engineering, medicine, already making inquiries about when can we use this service. So hopefully, we should be able to sell our 140 tapes. As it's a research facility, the school covers the cost, so if we do badly, they will top up the final cost. But they will help us with the running of the facility. So we had to come up with this model, which we know people can actually afford to use based on their grants. We're providing 10 years of storage, even though you only might have a 3-year grant, which is more than we have now. So what did we get? We ended up getting a Spectralogic T950 and a Verdi disk, and we used the QStar Active Archive software manager. Some of you might know of QStar. The reason we chose QStar is it's active archive, so it's a mixture of disk and tape. You deposit the file onto disk, it eventually migrates to tape, but it leaves a copy on disk of the most recently accessed files. So if you come back tomorrow, there's still a copy on disk for you to use as well. And this gives us the ability to do data where people want to deposit stuff and forget about it, deposit stuff over 6 months, access their data, then maybe pull it all back and do post-processing. Or it could be something like the wind or the input data where people are reading every day. You read in 1 year, loads it onto disk. The next day, you load a different year, pulls that onto disk, pushes the other files out. So it gives us the ability to handle lots of different data types and access patterns with the one system. And the big requirement was it had to be a file system which professors could understand. Had to be something simple which they're used to using. Normal Linux file systems where they can change directories, lay out the data how they want to store it in the first place, because that's how they work now. There's no point giving them a big fancy find my data interface. They'll never use it. They will change directories into a document called data. And we also set up a website with a few forms where we can register projects, people can buy tapes online, we can associate them with the data, messages. We've also used the XML interface to the Spectra library to monitor various hardware, things like temperature, current and so on. And we also have a few other monitoring tools in there where we're using to monitor people's actual usage of the facility. Whenever they use their tapes up, so we can tell them to buy more tapes, how is the cache performing, things like that. This is still partially hypothetical. The system's past acceptance testing. We're doing the first pilot in about a week. So, as I mentioned, there's different types of scenarios for how people use the service based on their data access and the type. Number of files, how often they deposit data. Some people might want to deposit data once every 3 months. Some people might want to deposit once a day. Some people might want to read back every day. People might want to read back once a year. So we came up with 5 different scenarios. We have what we call near online data, which is a large cache, which is data files which are used as input to simulations like WIN files, ancillary files, stuff which is going to get read randomly every day by someone. What we call deep online, which is data where people want to deposit stuff and forget about it. It might be 6 months before they finish storing all their data, then they might want to read it back then. That doesn't need such a large cache, 1 or 2 copies. And the third scenario for the really paranoid data where it has to be perfectly safe, we will have a remote site using something like Iron Mountain, which is a secure facility for storing data and tapes for people who want that extra security. So in terms of what the users see, it looks like another file system to them. They just CD into another NFS disk and copy their files there. That's all they have to do. But to them, they don't know that it's necessarily disk or tape. We're going through a training exercise where we have to remind them that it might be tape, so don't expect your file to come back instantly. It might be a few seconds, might be a few minutes. So there could be delays in loading the data, but people have to realise this is not an online disk system. We've set it up so we can access it via Linux and Windows as well, because we have a few Windows users, with the appropriate security in so people can use their group and nominate a few people who have write access and give read-only access to other people. We don't want the PhD students coming in, dropping petabytes of files because they don't know what they're doing. We will nominate a few people who are allowed to moderate, check the data, and store it to tape, because they're going to be financially responsible for it. We've had some issues with some of the security access through QStar, so we've agreed on having a central server for each school to use, a central point which has the right permission set up and accesses for people to drop their files into the service. We didn't want to make it like a general NFS disk, because everyone would just treat it like disk. They have to go through the effort of moving it somewhere special, so they realise they're moving it to tape. This also comes from the fact that when we planned this system, we always knew we wanted to extend it to the whole university. The university hasn't done it yet, so we stepped in. We've got a system now which we can extend, but we have to think about how do other departments use the system. Different users, different security procedures. So each department that joins the service will have their own little server, a central point where they can access the facility from. We don't want the file systems mounted by 100 different people over the university. That's just going to cause problems. We've got to nominate select machines, which is going to help reduce those issues. So this is finally going to give us the start for the long-term storage for the research data that we need. Instead of deleting everything, we now have a method of storing our data. And the big thing was we needed a system that could grow to meet our needs. We all know how of the exponential data growth. We are no different. New models come along, new high-resolution microscopes, new equipment that will generate data at 4 times the resolution. We have to try and plan for that. That's it.